Good morning, students. Welcome back to this algorithm class. We are discussing about grading method. In the last few classes, we discussed about knapsack problem and job sequencing problem. They were solved using the grading method. You know what is the grading method is? The grading method will have some n inputs and there will be objective function and the constraints. The solution set, the elements of the solution set should satisfy the constraints and contribute a value to the objective function. Your aim is to maximize or minimize the objective function depending on the nature of the problem. And that's what we have discussed about grading method. And the problems of grading methods might be of two categories, namely subset paradigm problem and order paradigm problem. In the subset paradigm problem, a collection of feasible solutions are derived, and one among the feasible solution is the optimal solution, and that has the maximum value or the very minimum value for the objective function. And this knapsack problem and job sequencing problem comes under the subset paradigm problem. Now we are going to discuss about this optimal storage on tapes problem. Okay, look at this. What is this problem is. So in the optimal storage on tapes problem, you are given some n programs and each program has a length Li, the length of that program. And we have to store these programs in a magnetic tape. The length of the magnetic tape is L. N programs have to be stored in a magnetic tape, and the length of the magnetic tape is L. Each program has a length Li. Okay. Let us assume that the programs are stored in the order I1, I2, I3 up to In. And we have to retrieve these programs from the magnetic tape. So there will be a time consumed in retrieving a program from the given magnetic tape. Okay. So the average time to retrieve a program is called mean retrieval time. This problem tries to minimize the mean retrieval time for retrieving a program. Okay, I give you a even more simple example. Maybe some 5 years back or 6 years back, you might have seen the tape recorder, cassettes. Okay, in the cassettes, there is a magnetic tape, and there we used to record songs or anything. Okay, usually we used to record songs in that magnetic tape. Some 10 songs are there, means then the 10 first song, second song, third song, like this one after another, the songs are stored. Okay, now the problem is in which order the given songs should be stored in the magnetic tape such that the retrieving time of a song is minimum. The retrieving time of a song is minimum. That is this problem. The optimal storage on tape means you are given some n program. Each program is having a length Li, and also you are given a magnetic tape of length L. You are storing the programs one after another in that magnetic tape. In what order the programs should be stored in the magnetic tape such that the retrieving time of a program is minimum. That is this problem. Okay. Now look at this example. Identify the optimal ordering for 3 programs with length 5, 10, 3. The length of the first program is 5. The length of the second program is 10. The length of the third program is 3. Okay. In what order these programs should be stored such that The retrieving time is minimum. The retrieving time is minimum. That is this problem. Okay. Now, since there are three programs, there are 6 different ways the programs can be stored. That is 3 factorial is equal to 6. So, the programs might be first program, second program, third program, or first program, third program, second program, or second 1 3, or second 3 1, or 3 1 2, or 3 2 1. These are the various orders the programs can be stored in that magnetic tape. If it is 1 2 3 means, then how the retrieval time is calculated? What is the length of the first program? 5. The length of the first program is 5. The length of the second program is 10. Length of the third program is 3. Okay. So, to get the mean retrieval time of this ordering 1, 2, 3, first you write the length of the first program. Then when you select the second program, you have to consider both the first and the second program. So, for the first program it is 5. For the second program it is 10. Then you select the third program. When you select the third program, you should consider first and the second, then you come to the 3. So like this, 5, 10, the length of the third program is 3. So when you add up all these things, you get the value of 38. Like this, 1, 3, 2. Okay. Length of the first program is 5. When you consider the third program, it is 5 plus 3. Then when you consider the second program also, it is 5, 3, 10. Altogether, it is 31. Like this, 2, 1, 3. 2, 1, 3. Okay. Length of the second program is 10. Then when you consider the first program also, that is 10 plus 5. Then when you consider the third program, it is 10 plus 5 plus 3. Altogether, it is 43. Like this 3, 1, 2 means, then the length of the third program is 3. Then the first program is considered 3 plus 5. Then the second program is considered 3 plus 5 plus 10. It is equal to 29. Like this, all these things are considered. Now you look at the retrieval time of these orderings. It is 38, 31, 43, 41, 29, 34. 29, 34. Now, which is the minimum? 29 is the minimum. So, this ordering is our optimal solution because that has the minimum retrieval time. Minimum retrieval time 312. Okay. That is the idea. Okay. Now look at, let us analyze this 312. Analyze these three. How they are stored in the magnetic tape. Look at this third program. What is the length of the third program? It is 3. Then first program. What is the length of the first program? 5. Then the second program. What is the length of the second program? 10. So 3, 5, 10. So the programs are selected in the increasing order of their length. Increasing order of their length. So that is the greedy selection here. Select the programs in the increasing order of their length to get the minimum retrieval time of the programs in the magnetic tape. That is the greedy solution. Now, how do you say this problem fits under greedy method? Greedy method. Here you are given some three programs, n programs. That is, n is equal to 3 programs are given. Then the greedy method should have an objective function. What is the objective function? To minimize the retrieval time of the program. That is the objective function. Okay. In the previous problems, we have maximized the objective function. Here we are minimizing the retrieval time. Then what is the constraint? A program selected for solution should minimally increase the retrieval time. Should minimally increase the retrieval time. That is the constraint followed here. So when you follow these conditions, this problem very well comes under the greedy method solution. So because we are taking some decision on every input selection. For every input selection, we are taking a decision. So it is a very simple example that shows the technique of greedy method. Let us look for another example. Another example. Okay. You are given 5 programs. On the length of the 5 programs are 12, 5, 8, 32, 7. Length of the 5 programs are 12, 5, 8, 32, 7. Now let us assume that no ordering is done here. No ordering is done here. They are selected randomly. They are selected randomly. Then they are selected as they are given in the problem. That means then first problem, second problem, third problem, third program, fourth program, fifth program. So when you consider the first program, it is 12. When you consider the second program, it is 12 plus 5. This is 12 plus 5. Then when you consider the third program also, it is 12 plus 5 plus 8. Then when you consider the fourth program also, it is 12 plus 5 plus 8 plus 32. Then when you consider the all the fifth program also, it is 12 plus 8 plus 32 plus 7. So when you add up all these things, you are getting the value of 175. 175. Now, let us go to this greedy selection method. Greedy selection. What did the greedy selection says? Select programs in the increasing order of their length. Okay. Now, which program is having the minimum length? 5. Okay. So the second program is having the minimum length. So that is considered first. That is considered first. Then which program is having the minimum length? 7. Fifth program. So then fifth program is considered next. Then which program is having the minimum length? 8. Okay. So third program. So it is third program is stored next. Then which program is 12? That is first program. Okay. Then fourth program 32. So it is considered last. So the order of storing in these 5 programs in the magnetic tape is 2, 5, 3, 1, 4. Now let us compute the mean retrieval time of these programs. Okay. What is the first program? Second is first program to be stored is the second program. Okay. What is the length? 5. It is 5. Then second program and the fifth program. So 2, 7. So that is 5 plus 7. Then third program is considered. So it is 8. So 5, 7, 8. Then the first program, what is the length? 12. So it is 5, 7, 8, 12. Then the last program, it is 5, 7, 8, 12, 32. When you add all these values, you will get 133, which is much less than 175. Much less than 175. So the optimum ordering is 2, 5, 3, 1, 4. So first store the second program, then the fifth program, then the third program, then the first program, then the fourth program in the magnetic tape. So if you adopt any other method, any other selection method, certainly the mean retrieval time will be higher than this 133. 133. So this problem is solved under the greedy method. Now you wonder whether this problem comes under subset paradigm problem or a order paradigm problem. Certainly this problem comes under the order paradigm problem because we are not leaving out any of the given n inputs. So in this problem, the number of inputs are 5. All the 5 inputs are taken for the solution. So this problem very well comes under order paradigm problem. Order paradigm problem. Okay. This is very nice. Yeah, very simple example of greedy method. Okay. We will discuss about this optimal merger pattern in the next class.